So today we are going to actually look into this lecture 20, Arenes and Phenol part 1. Yeah, so you can see we have learned about electrophilic substitution. Yeah, benzene react with bromine, yeah, benzene react with chlorine, and also methyl benzene, they react with Cl2 and Br2 to get a mixture of products. So if you look at the mechanism of the reaction, yeah, so this one, okay, everyone should know by this time, okay, if you have a benzene, then you are going to react with Br2, you require AlBr3, okay, as a halogen carrier, okay, and then you are going to get, okay, the bromobenzene, okay, plus the HBr, okay, but okay, what is important over here is to know about the mechanism of the reaction. So if I draw the mechanism of the reaction over here, okay, it's going to be the AlBr3, okay, they are going to join with the Br and Br, okay, but before that, you need to show them, okay, the curly arrow, yeah. So they are going to actually AlBr3 is going to polarize the Br, okay, and they are going to get delta negative and delta positive. This one will come over here. You will get AlBr4 minus, and then you have Br plus. Okay, this Br plus is going to be your electrophile. Okay, once you have that electrophile, okay, you will have this benzene, okay, with the electrophile. Okay, this one will come over here. You are going to have, okay, this one is incomplete. Okay, so I'll just put like this. Okay, new bond is going to be formed. Okay, the previous bond. So this one, okay, the electron pair will come inside, and you will have the bromobenzene. Okay, and then you can just leave the H plus just like that. It's okay. Okay, but you should know that they can react with this. Yeah. So anyway, okay, the mechanism of this reaction is going to be the same for these two. Yeah. But what is extra thing that what are the extra things that you need to know when it comes to methyl benzene? Okay, methyl benzene. Okay, they are going to be methyl group is going to be electron donating group. Okay, therefore they are going to be 2,4,6 directing. So if they are 2,4,6 directing, so when you have the Br2, for example, okay, what will happen? Okay, the methyl group is going to direct the Br, okay, to go to position number 2. Okay, it will go to position number 2, or it will actually direct the methyl is going to direct the Br to go to position number 4. Okay, and 6 is going to be the same as this, so we are not going to write over there. So these are the two, yeah. So plus HBr, okay, it's not balanced, okay. But if you have, okay, methyl benzene, okay, and you have the Br2, but the Br2 in excess, for example, do remember you still need to have AlBr3. AlBr3, the halogen carriers must be there, okay, in order to have direct substitution to the ring. So here, what is going to be different over here is going to be there will be double substitution, like the Br will come here, the Br will come over here. Or you can have a situation where you have the CH3 here, Br will come here, Br will come over here, and you have another situation where you are going to have all the Br at position number 2, 4, and 6. Okay, and of course you will have HBr. Okay, this is going to be, if you look at it, okay, 3 electrophilic substitution reaction, yeah, 3 reactions, okay, and the mechanism. So I'll just move on. Okay, you see sometimes, okay, we do have free radical substitution. Okay, benzene, they do not undergo free radical substitution. Yeah, so only methyl benzene, any alkyl benzene, they undergo free radical substitution. But the thing that is required is going to be, it must be boiling. Yeah, the methyl benzene must be in boiling, and then you need to have UV light. Okay, you are going to have, okay, one of the H is going to be substituted. Yeah, you get something like this, and then the reaction will continue. Maybe, okay, you are going to have further substitution, CHCl2, and then it will continue. You will have, okay, the CCl3. Okay, so the reaction can continue. Okay, but okay, do remember the Cl will not enter, okay, it will not enter directly over here, okay, because why? There is no electron, there is no halogen carrier. Okay, so please remember that. Okay, that's free radical substitution. Now, then we go into this nitration of benzene. Nitration of benzene is going to be another form of electrophilic substitution. Okay, and under nitration, this is going to be the main equation. Yeah, so where the H is going to be substituted by NO2. Yeah, and you get water. But when you are going to write down the mechanism of the reaction, things are going to be different. Yeah. So you need to have a nitrating mixture, which is going to be concentrated H2SO4. You react with concentrated HNO3. And this reaction is done at 55 degrees Celsius. So you see, according to your syllabus, it's 25 degrees Celsius to 60 degrees Celsius. Yeah. So you are going to need to write the equation. So I'll write down the equation. This one, I told you, if you want to memorize, you can memorize. But in the end, what you are going to get, you are going to get the electrophile. This is the main important thing. Yeah. So this is going to be, you will get this and 2H2SO4 minus. Okay, so you are going to get this. Okay, you are going to get this. HSO4 minus. HSO4 minus. Okay, so you are going to get that. Yeah. So once you get that, okay, you have the benzene over here. Okay, the benzene, and you have the NO2 plus. Okay, this one same. Yeah, I'll just quickly write for you. You will have this. Okay, new bond NO2 and then H. Okay, so next one is going to happen. This one will come in, okay, and you are going to get the nitrobenzene, okay, and you can just leave the H plus just like that. It's okay. Now, this reaction is going to continue because why? Just now CH3 is going to be 246 directing, but this is going to be electron withdrawing group. NO2 is electron withdrawing group. They are going to activate position 1, 3, and 5. Position number 1 is already taken. Yeah, so they are going to activate 1, 3, 5. So further nitration is going to actually happen where you have the NO2. The NO2 can also come at position number 3. Okay, and then the reaction can continue where you are going to have further nitration where the NO2 now can actually come at position NO2, position 1, position 3, and position number 5. Okay, so this is what they meant over here. Yeah, so this one done also. Yeah, nitration. Next, okay, we went through this. Okay, electron withdrawing group. Okay, this is going to be electron donating group. Okay, but now we are going to focus on this OH. Yeah, phenol. Yeah, phenol is also electron donating group. Yeah. So, but before that, before we go into that, okay, we will look into this alkylation and acylation. Yeah. This alkylation and acylation is known as Friedel-Crafts reaction, and you need to have the catalyst and the heat. Yeah, catalyst and the heat. So, to make it faster, I will show both over here: alkylation, okay, and acylation over here. So if you look at alkylation, okay, alkylation. So let's say, for example, I have a benzene and I'm going to react with CH3Cl. This is alkylation. Yeah, you're going to bring the CH3 into the benzene ring. In order to bring them into the benzene ring, you need to have halogen carrier. So you need to have the halogen carrier. And according to your syllabus, you need to heat. Yeah. The same thing here. Okay, I have a benzene and I'm going to have the acyl group. Yeah. So you can have this one as an acyl group. Yeah. C double bond O Br. And this one maybe rather than using CH3, maybe I'm going to use C2H5. Yeah. So in order to do this, yeah, so still need to have the halogen carrier, but I'm going to use AlBr3 because Br. Yeah. And then heat. And let's look at what will happen, okay, when it comes to the mechanism of the reaction. So the mechanism of the reaction is going to be first, okay, the same. You bring the CH3Cl over here, okay. I think better if we show like this, okay, hold on. CH3Cl, I show like this, okay, and then I have the AlCl3. AlCl3 no need to polarize because the Cl itself is going to be electronegative. They will change like this, and this one will come over here. So you are going to have, okay, AlCl4 minus, okay, and then CH3, okay, electrophile. Okay, the next is going to be quite simple. Okay, very easy. Okay, you have this benzene and you have CH3 electrophile. Okay, this one will come over here and you will have this one incomplete and you will have CH3 and you have the H over there. Okay, what happened next? This one will come in and you will have the methyl benzene done. Yes, methyl benzene, and you can just leave the H plus if you want over there, but they do react with the AlCl4 plus. Yeah, sorry, not plus. Okay, my mistake. Okay, this one minus. Okay, minus, and then this. Okay, so here. Okay, the next part is going to be acylation. Yeah, acylation. So acylation is similar. Okay, you have C2H5, C double bond O Br. Okay, reacting with AlBr3. So same. This one will go here, delta negative, delta positive. This one come here. Yeah. What will happen? You are going to have AlBr4 minus, and then you have C2H5. And then C double bond O, and then plus. Okay, so this is going to be your electrophile. Okay, once you get that electrophile, okay, you are going to have the benzene. Okay, and then you react with the electrophile C2H5, C, and then plus over there. So this one, okay, they are going to come over here, and they are going to have, okay, something like this. Okay, plus, and then C double bond O. Okay, and then I put C2H5 and then H. Okay, so the next part, okay, is going to be having, okay, having the H coming in here. Okay, so you are going to have, okay, you are going to have, sorry, you are going to have, okay, this one, and then C double bond O, okay, then C2H5. And then plus H plus. Done. Yeah, done. So this is going to be the mechanism of the reaction. Yeah, the mechanism of the reaction. Okay, which you need to follow. Okay, so this one is done. Yeah. So next is going to be the oxidation. Okay, the oxidation of the side chain in arenes. Yeah, do remember normally oxidation don't happen. Okay, but for benzene there is no oxidation. For methyl benzene, any alkyl benzene, yeah, methyl benzene, let it be, you have the benzene with a C2H5, you can oxidize them, okay, but the product is always going to be benzoic acid. Yeah, so the benzoic acid, this is going to be the benzoic acid. Okay, so you are going to get, okay, a benzene, okay, with, okay, COOH. Sometimes you'll be wondering, here I have 2 carbon, why there is only 1 carbon here? So the next, the another carbon may be converted into carbon dioxide. Yeah, so the products will be carbon dioxide and water. Yeah, but if it is methyl benzene, yes, 1 carbon, no carbon dioxide. So you'll have that. Okay, but another thing that you need to remember are the conditions. Okay, the conditions are going to be, okay, they mentioned it's going to be reflux or hot. Yeah, so reflux, okay, reflux. Important, it's going to be alkaline. Yeah, alkaline KMnO4, because normally we have it in acidified KMnO4. This is going to be alkaline KMnO4, and later only they add, okay, they add dilute acid. So the dilute acid, maybe you can add the H2SO4. Yeah, so that is going to be slightly different. Yeah, slightly different than the normal oxidation that we used to do. Okay, when it comes to alcohol and so on, so slightly different. Yeah, so next part, okay, oxidation. Yeah, the next part, okay, is going to be the last equation or last reaction when it comes to benzene. Now benzene, okay, I told you that they have this localization of electrons in the benzene ring, okay, making it stable, and they do not undergo electrophilic addition reaction, okay, because the benzene ring is going to maintain the stability of the molecule, and that is called aromatic stabilization. Now this aromatic stabilization is going to make it like electrophilic substitution reaction is more favored over electrophilic addition reaction. So they don't actually go through electrophilic addition. Why? Electrophilic addition requires harsher condition. Yeah, but there is going to be, even though they say harsher condition, that doesn't mean electrophilic addition cannot happen. Okay, they still can happen under harsher condition. So the harsher condition, okay, one example in your syllabus that they require you to know is going to be hydrogenation. So you are going to add hydrogen with the catalyst platinum and nickel. Yeah, with heat and high pressure. And this reaction is not something new, because last time you have learned, okay, hydrogenation with alkene, okay, with hydrogen, okay, they will give you with platinum and nickel, and the temperature is 140 degrees Celsius, if you remember. Yeah, they are going to have the double bond broken, and then the H and H will come over here. So that is going to be hydrogenation. So here we are going to assume, yeah, that this one is going to have the double bond over here. Assumption only lah. Yeah. So what happens? Okay, one of the H over here, okay, the double bond is broken. So previously they used to have each one used to have H. So now one new H will come after the double bond broken. So you have new H, double bond broken, another new H. So double bond broken, new H, double bond is broken, so new H, double bond broken, new H, double bond broken, new H. So you are going to get, okay, a molecule without, yeah, without like the double bonds or without the circle, yeah, and you are going to have each of these have 2H. So do remember this is C6H12, or they are known as cyclohexane. Okay, so this one requires nickel and platinum, but they mention heat and high pressure. Okay, but okay, do remember, okay, benzene, they are stable. Okay, if last time we used 140 degrees Celsius, I'm very sure that this is going to be greater than 140. Okay, but in your syllabus, they didn't specify. They say heat is okay lah, to say high heat and high pressure. So it's still okay, fine, yeah. So here, okay, these are all the reactions that we have learned under benzene. So now, okay, we are going to come into phenol, the one that I introduced to you yesterday. Now, phenol, when you look into phenol, yeah, phenol are generalized as weak acid, yeah, similar to water, similar to ethanol. So they are going to be incompletely dissociated to give you the H+, okay, to give you H+. So they are going to be partially dissociated. And when we look into weak acid, generally we look at the pKa or the Ka value. If you have higher Ka, it means more dissociation. Okay, more dissociation means there is going to be, the weak acid is going to be more acidic, yeah, more amount of H+. And if you change it into pKa, okay, pKa is negative log, yeah, similar like pH, okay, if you have lower pH, it means that it's more acidic. So similar, pKa is going to be, if you have lower pKa, that means it's going to be a better weak acid. Okay, Ka is used for weak acid, so it's a better weak acid. It means the H+ is more. So if you look at this value 10, 14, and 16, this is going to be the lowest. It means that phenol, okay, is going to be a better weak acid. Yeah, that is going to be a simplified version. Now phenol is going to be, this is going to be the structure. It is a crystalline solid with high melting point. The melting point is high because of the presence of hydrogen bonding with another phenol, okay, and this is going to be normally anything that has hydrogen bonding, they can form hydrogen bonding with water. Yeah, so in this case, phenol can form hydrogen bonding with water. They should be soluble in water, but they are going to be slightly soluble in water because the presence of this ring, yeah, the benzene group over there is going to be a large non-polar structure. So if you have large non-polar structure, they will disrupt the bonding, yeah, of this phenol with the water. The hydrogen bonding is going to be disrupted. So if it is disrupted, okay, the bonding is not that strong. It means that they don't dissociate easily when it comes with water. So they are only slightly soluble in water. So please take note. And they are weakly acidic, I already told you. They will give you this ion called phenoxide ion, okay, similar like C2H5. If you have C2H5OH, they will give you C2H5O minus and H plus, okay, ethanol. So this one, we call it as ethoxide ion, okay, ethoxide ion. So phenoxide ion, ethoxide ion, yeah. The position lies to the left-hand side. Why? Generally, all these, not only phenol, all these, the position are going to be lying on the left-hand side. Because why? They are partially dissociating. So it means that the phenol, water, and ethanol, they tend to exist in undissociated form. Yeah, that's why if you look at water, water can conduct electricity or not? Yes, because they have free moving ion. Okay, but that water is not a very good electrical conductor. Why? Because the amount of free moving ions are little. Yes, because most of the molecules that exist in water is going to be in undissociated form, H2O. Yeah, that's the meaning. The position is going to be lying on the left-hand side. Okay, but whatever it is, if you compare with these three molecules, okay, phenol is still a stronger acid than water and alcohol. So do remember that. Yeah. So in your syllabus, okay, they want you to know about the preparation of phenol. So that's why I told you, okay, I explained to you yesterday about the diazotization. Yeah, what is diazotization? Diazotization reaction is going to be a reaction, okay, that we are going to prepare for dyes. Yeah, so this is diazotization. So in order to do that, okay, we start from phenylamine. Yeah, what is phenylamine? Phenylamine is going to be a benzene, and you put the NH2 over there. So this is phenylamine. So what happens is, okay, there is going to be a reaction with phenylamine and HNO2. Yeah, so HNO2. Now HNO2 doesn't just simply like comes in a bottle. Yeah, so you need to prepare. Yeah, because why? The nitrous acid is unstable. So you need to prepare. How do we prepare? Okay, we prepare by using NaNO2 and HCl. So this is very important. So this is going to be the HCl is dilute HCl. Yeah, you can check from the syllabus what they mentioned. Yeah, and the reaction must be at 10 degrees Celsius, because if you go more than 10 degrees Celsius, the nitrous acid, they will actually decompose to give you N2, nitrogen gas, which we don't want. Okay, so the first thing is to know the equation. Yeah, so you prepare NaNO2 with HCl, they will give you the HNO2, the one that we want, and the NaCl. I think simple equation. Yeah, so the reaction, let's go directly to the equation. So this is phenol, okay, phenylamine, okay, they will react with HNO2. They still react with the dilute HCl. Okay, so still react with dilute HCl. What will happen? You are going to have, okay, the nitrogen over here and the nitrogen over here. Okay, they are going to have N2. So nitrogen and nitrogen. Okay, and you will have the Cl over here. Okay, so you have the Cl over there. So if I put it in simple form, you are going to have a benzene, okay, with N2 plus and Cl minus in simple form. Yeah, in simple form. And what is going to be, what are the other things that is going to be formed? Okay, so the other things that will be formed, you see, there are hydrogen, okay, two hydrogens, okay, there are two hydrogens. There is another hydrogen over here, okay. There is two oxygen over there, okay, and then there is another H over there, okay. So I have 4 H and 2 O, yeah. So I can join them, okay, to give you 2 H2O. Yeah, I can give you 2 H2O. So basically, you are going to get benzene diazonium chloride or benzene diazonium salt. Okay, so this is very important. You form the salt. Yeah, once you get the salt, okay, now we look into, this is going to be apart from diazotization. Yeah, so this is apart from diazotization, and this is more towards, okay, the formation of phenol. Yeah, but if you want to continue with diazotization to form dye, later I will show you. Okay, there are part 2 reaction for this. Yeah, this is step number 1 only. But now we look into preparation of phenol. Yeah, so once you get the benzene diazonium salt, okay, you are going to heat with water. Okay, heat with water. Do remember, this is going to be a circle. Yeah, heat with water, and what you are going to get, I will rewrite again. Yeah, so you are going to get N2 plus, okay, and then Cl minus, okay, and then you heat with water. Okay, heat with water. What am I going to get? I am going to get, okay, this phenol. Okay, phenol is going to go there. Okay, earlier you have N2Cl. Okay, and do remember there is H also. Okay, there's H. Okay, and there is also reaction with water. Okay, so what I am going to get, Okay, nitrogen will come, okay, over here. So the rest is going to be this H and Cl. Yeah, so H plus HCl. So the reaction over here, okay, when I look at it, yeah, so what happens? The H2O, one of the H come over here, another OH goes over here. So that is the meaning why you have the H2O. Okay, but I hope you understand. But in the end, okay, if you look at it, if I want to write down the preparation of phenol, yeah, okay, if I want to write down the preparation of phenol, you should know, yeah, how to write the preparation of phenol. So I'll just go through this again with you, yeah. So preparation of phenol, okay, is going to start off, okay, by, okay, preparing the HNO2. Okay, you need to prepare HNO2. So how do you prepare HNO2? You prepare with NaNO2, react with H, okay, react with HCl, okay. You are going to get HNO2, okay, plus NaCl. Okay, very simple. Yeah, and you are going to have this reaction being done at less than 10 degrees Celsius. I will use 5 degrees Celsius over here. Yeah, so once you get this acid, okay, once you get this acid, okay, you are going to react with the phenyl amine. Okay, you react with phenylamine. Okay, once you react with phenylamine, what will happen? Okay, this is going to give you the N. Okay, you will get 2. Okay, the N will be 2, and then plus. Okay, you will have this, and don't forget about ACl. You see, I already forget about ACl over here. Okay, plus HCl. Okay, I am going to get the Cl minus over here. And the leftovers, okay, are going to be, you are going to have, okay, nitrogen already used, okay, and then Cl already left. Yeah, so basically you are going to have water, okay, how many you can actually calculate, and you will get 2H2O. Okay, once you get that, okay, so basically the next step is going to be, okay, it is going to be, we are going to look into how do we prepare phenol. Yeah, so this is going to be just the first part for the preparation of dye. Yeah, diazotization. Okay, so this is just the first part. Okay, but now we hold on to the first part. Later we'll go for the second part. Okay, but now I want to use this to prepare. Okay, this to prepare phenol. So how do I prepare phenol using this? So again, I have the benzene diazonium chloride, so N2 plus Cl minus, okay. I react with H2O, okay, and I need to heat, okay, I need to heat. What will happen? I am going to have, okay, the OH come over here, okay, and I am going to have nitrogen gas, okay, and I am going to get HCl. Okay, done. Everything is going to be balanced. Yeah. So this is how you produce the phenol. Yeah. And do remember the next part of the phenol is going to be phenoxide. Yes. So straight away, if you have phenol C6H5OH, they have tendency to give you C6H5O minus and H plus. So this is phenoxide. Now this phenoxide, okay, the negative charge, okay, what will happen is the negative charge or the lone pair of electron has tendency to join, okay, or overlap, okay, with the pi bonding or the benzene ring. Yeah. So what will happen? They have this tendency to go there, and this will actually spread the negative charge all over the phenoxide ion. Yeah. So because why? They overlap with the pi bonding system. Yeah. So what happens? This negative charge is going to be, because they are going to be equally shared. Yeah. It will go inside. It will become less density. The density of the charge. Yeah. The less density over there. The negative charge is not that concentrated at oxygen. Yeah, it's not concentrated at oxygen atom. So what happens is, if you have less negative over here, the positive and negative, they are going to be less attracted. Okay, they are going to be less attracted. If they are less attracted, they are not going to join together to form this. So it means that they have the tendency to form, okay, they have two tendency, right, to form this and that. Okay, so if they have less attraction over here, it means that this one will be lesser. Yeah, the reaction is not going to go backward. Yeah, it will tend to go to forward. So in that procedure, if you have a forward reaction, it means you are forming more H plus. If you are forming more H plus, that is going to actually mean that it is going to be a stronger weak acid. Why? It is going to actually give you more concentration of H plus. Yeah, that is one of the explanation. Another explanation is, okay, this molecule, yeah, the phenoxide ion, if you donate the electron or the overlapping with the pi bonding system, this ion is going to be stable. Yeah, so if you look at the equation, they always like to form something that is stable. Yeah, so if you compare a phenoxide ion and phenol, yeah, if you compare this with the normal phenol, okay, if you compare this and normal phenol OH, this is going to be more stable, okay, compared to this. Okay, so this is another important thing. Yeah, phenoxide ion is more stable compared to phenol. So in chemistry, we always like to form something that is more stable. Yeah, so that's why, okay, the reaction, if you have C6, if you have C6H5OH, when they form this C6H5O minus plus H plus, they want to form something that is stable, and we know that this is stable, so they tend to form something stable. Okay, the position is going to be shifted to the right, so you are going to produce a lot of H plus. That is the explanation, two explanation. Yeah, why the phenol has is a weak, is a strong, is a better weak acid. Yeah, you must be very careful with the term, a better weak acid. So if you compare this, okay, with ethanol, yeah, ethanol is going to be slightly different. Yeah, C2H5OH. Yeah, so they are going to give you C2H5O minus and H plus. Okay, do remember C2H5O minus, okay, C2H5 is going to be electron donating group. Okay, they tend to donate electron. So when they tend to donate electron, there is already a lot of electron, yeah, at oxygen. Okay, and if you donate electron, what happens? The charge density will increase over here at oxygen. So if the charge density increases over there, it means that the reaction between H plus and negative over here will be better. Okay, if this is better, of course, they are going to have more reaction to form the C2H5OH. Yeah, so that is going to be happening. So if you have more of this, it means the concentration of H plus is going to be less. Okay, if you have less concentration, that makes, okay, ethanol to become a weak acid. Yeah, compared to phenol. Yeah, I hope this one you can understand. Yeah, the rest of it, I think whatever that I explained, I already put it over there. Okay, but okay, let's actually go directly to reaction of phenol. Yeah, the reaction of phenol. Yeah, phenol generally, I told you, they are weak acid. So they will undergo all the reactions that a weak acid supposed to undergo. Okay, like for example, they will react with sodium hydroxide. Okay, acid with sodium hydroxide, acid with alkali, they will form salt and water, the same. They are going to actually have, okay, this O, okay, will be staying there, and this is going to, the Na plus is going to come over here, okay, and then you are going to have the H and OH to give you water. So that's why you are going to have this salt, which is going to be known as sodium. Okay, sodium, and remember just now I call it as phenoxide ion. So this is going to be sodium phenoxide ion. Okay, if you are still wondering why phenoxide, why benzene becomes phenoxide, remember I told you phenol. Okay, C6H5. okay, is always known as phenyl group. Yeah, so that's why they are going to be known as phenoxide. Yeah, so this one, if you have OH, then phenol. Yeah, so now this is going to be sodium phenoxide because there is oxygen. Yeah, so sodium phenoxide. Yeah, so I hope you understand this part. Okay, next part is going to be, it will react with sodium metal. So do remember, yeah, acid, okay, whenever they react with sodium, there is going to be vigorous reaction. The same, they are going to react vigorously to form hydrogen gas and the salt. Yeah, the same reaction. So you are going to have this O and A. So supposed to be, okay, because they are going to give you, if you in normal condition, then it's supposed to be just half H2. Yeah, so you don't want the half over there, you want to times everything by 2. That's why times everything by 2, you will have all these 2 in front. Yeah, but basically you are going to get salt and water. So here what is the reaction that we see over here is going to be, you can react with sodium hydroxide, you can react with KOH. Okay, doesn't matter, you can react with sodium, you can react with lithium, you can react with magnesium. So still same. Yeah, so even though they didn't go through this, you should know. Yeah, the phenol, okay, they can react with sodium, they can react with sodium hydroxide, potassium hydroxide, and so on. Yeah, and the next reaction, okay, remember, okay, I taught you the beginning part, okay, the diazotization, the preparation of dye. Okay, you get benzene diazonium chloride. Then after that, I add with the water and change this into phenol. Okay, under the production of phenol. But now, okay, we want to see the reaction of phenol. Yeah, there is another reaction of phenol. Okay, and they are involved in this formation of dye. Yeah, so that's why they call it diazotization. Yeah, the diazotization, they will continue because remember the benzene diazonium chloride, one of the reaction is going to react with water to give you phenol. Okay, but another reaction is going to be, okay, another reaction is going to be, they are going to react with phenol, okay, to give you the dye. And the dye is going to be a orange color dye. Yeah, so orange color dye. So let's actually look at that reaction. So that reaction is called coupling reaction. Okay, what is coupling reaction? Basically, they're going to couple one benzene ring with another benzene ring. Yeah, so you see, this is going to be the diazonium salt. They have removed the Cr minus, yeah, because not required over here. But if you still want to have the Cr minus, also can. Cr minus will come over here. So in the end, you are going to get H plus and HCl, Cr minus. So basically, they will give you HCl. Okay, if you include the Cl. Yeah. So anyway, they are going to react with phenol. Okay, do remember, okay, this is going to be the previous information will come into play. Okay, OH is electron donating group. So they are going to be position 246 activating. Okay, but for this reaction, because we are dealing with benzene ring, a lot of big stuff. If you have a lot of big stuff, they are going to, because of the structure, yeah, they are going to activate position number 4. Yeah, because that is going to be, if you put them in a different place here, not enough space, you put them over here, not enough space, but if you put them here, a lot of space. So they will select position number 4. Yeah. So when you select position number 4, what will happen? Okay, you are going to have this phenol. Okay, you are going to have this phenol. Phenol is here, and they are going to form a bond. Okay, they are going to form a bond. Okay, with what? They are going to form bond with this hydrogen over here. Yeah, here. Yeah. So what happens? Previously, they used to have hydrogen. Do remember, they used to have hydrogen over there. Okay, what happened? They are going to remove that hydrogen. Yeah, they are going to remove that hydrogen. So you are going to have, okay, the reaction. Okay, and you join with this N2. Okay, join with this N2. And straight away join with this, okay, and this one, okay, they just no need to show the hydrogen, is still going to be there. Okay, so that's why if you're wondering, okay, the H plus is coming from where? The H plus is actually coming from here, okay, the one that used to be here, okay, this H plus, okay, that's why they put it over there. So if you, if I draw for you again, yeah, of course you want to see, okay, so you are going to have generally, initially, I have this N2 plus Cl minus. Okay, this is benzene diazonium salt. Okay, I am going to react with phenol. Okay, this is normally when we write, we actually tend to write it this way. So what happens if you want to write it this way also, I leave it to you. Yeah, you are going to have a phenol. Okay, you are going to get a phenol. The H over here is going to be replaced, so I just put H plus. Okay, and then the Cl will come over here, so Cl minus. Okay, and then they are going to come over here, so N. Okay, N2, so it's going to be double bond N. Okay, and then join with this over here directly. Okay, so you are going to get this molecule. So if I want to rewrite this properly, I can actually put it, let's say, for example, N and N over here. And then I put over here, okay, you will have a benzene molecule here and another benzene molecule with the OH over here. And then I put HCl. I think this is the best way that I can show you. Yeah, and this is what we call the orange dye. Yeah, the orange dye. So that we need to prepare for the diazotization reaction. Yeah. So anyway, okay, do remember this reaction. Yeah, the reaction that you have, this one coming over here. Do remember that this reaction is going to substitute into the benzene ring. This is very important. When it is substituting into the benzene ring, this is also going to be electrophilic, okay, electrophilic substitution reaction. Do remember this, yeah, electrophilic substitution reaction, yeah. And here, okay, you do notice that they didn't use any form of catalyst. Okay, they didn't use any form of catalyst. Okay, why? We will explore it later. Yeah, because the phenol, okay, have is a very special molecule. Yeah, phenol is a very special molecule. They do not require catalyst because the reaction can really happen without the catalyst. Yeah, the reaction can happen without the catalyst. Okay, we will explore that later. Yeah, because normally we need to have the catalyst. Yeah, but for phenol, we didn't go into detail yet. Yeah, but that is what we are going to go now. Yeah, which is going to be the next part of the lecture, which I will actually go through also on this Thursday. Yeah, but if you look at it, okay, we are going to have, okay, electrophilic substitution of phenol, okay, which is going to be your halogenation, okay, or bromination. In your syllabus, they say bromination. They do not require Cl, yeah, they require Br, but if they require Cl, yes, it's still the same. Okay, the reaction is going to be Br2 aqueous to form this, yeah. So you see it reacts, okay. What reacts more readily? Yeah, phenol reacts more readily. Why phenol reacts more readily with the electrophile? Because the OH is going to donate the electron into the benzene ring. So when the OH is going to be donating the electron into the benzene ring, they are going to increase the density of electron in the benzene ring. So you do not need to have any halogen carriers to go and attack the benzene ring, because now they are very the density is going to be very high until, okay, the electrophile, the moment they see the electrophile, they do not need to ask permission. Okay, come, I need a third person to help me. No need. Okay, they will straight away go and attack. Yeah, the electrophile can attack, okay, easily. That is going to explain why there is no catalyst over here. No need catalyst. Okay, why? Because phenol is going to be very reactive, or the density over here is going to be very high, so that the electrophile of this salt, they can straight away come over here, okay, and attack. Okay, so it's going to be easier for the reaction to happen. Okay, so that is going to be the thing. And then they are not going to be substituted, one by one, because they are very high density. So it is similar like bromine is going to be in excess. They are going to actually straight away go and activate because OH is going to be 2,4,6 activating. They will not form like our previous reaction with methyl. Yeah, the methyl they activate with what? They activate position number 2 first. Okay, then after that they activate. There is going to be a mixture at position number 4, and then when excess only, you are going to have combination 2, 4, and then you have. Okay, I'll just straight away show you. Yeah, just now. Okay, what we did. Okay, for methyl. Okay, if you look at the methyl, okay, you see without like normal condition, you have 1 by 1 mixture. When it is excess, you have this combo, and then you have the final combo. Yeah, but when it comes to phenol, they go directly to the jackpot. Yeah, they go straight away. Yeah, they go straight away. Why? Because they are very reactive. Okay, they are very reactive, so they are not going to go here and there. They will go straight to the point. Yeah, they will go straight to the point. So it means that they will go at position 2, 4, 6 directly, and you will have this. Yeah, so they decolorize orange water to form white precipitate. This is going to be white precipitate. Okay, and the reaction will react. Okay, but milder condition. Yeah, so you do not need to have halogen carriers. Okay, you do not need to have halogen carriers like just now. Okay, like normal situation, what we need. Okay, you need AlBr3. Okay, you can see you need AlBr3 catalyst. Okay, catalyst, and here they didn't say heat. Yeah, they didn't say heat, so they just going to use the catalyst. Yeah, but this one is going to be milder. Yeah, so it's still going to be much more. Okay, it's very reactive. Basically, phenol. Okay, I'll just put down over here. Phenol is more reactive. Okay, more reactive. Okay, then what? Even more reactive than methyl benzene. Yeah, more reactive than methyl benzene. Methyl also donating the electrons, but phenol, the OH will donate more. Yeah, so they are going to be more reactive. So if you look at the other reactions, electrophilic substitution of phenol, yeah, other reaction like nitration. Yeah, remember like last time, okay, when you have nitration with benzene, you are going to prepare using H2SO4 concentrated and HNO3 concentrated, and you are going to get the NO2. Yeah, I just rewrite again. Yeah, NO2 H3O plus, and then 2HSO4 minus. This is with benzene. Okay, why? You need to prepare. You need to prepare first. Okay, but now, okay, you do not even need to have concentrated acid or concentrated nitric acid. Even with dilute nitric acid also okay. Okay, straight away. And you do not need to have sulfuric acid because they just directly with nitric acid, they can actually get the electrophile. So that is telling you that the phenol is very, very powerful. Yeah, they will bypass the reaction. Okay, they will straight away, they just need the dilute HNO3. Okay, they are going to actually get, because do remember this one is 2, 4, 6 directing. So they will go to position number 2 and they will go to position number 4. Yeah, so they are going to be 2, 4, 6 directing. Okay, so they no need to show position 6 because it's the same as this. Yeah, but okay, this is when you are using dilute nitric acid. Another one more thing that I want to remind you. Okay, nitration just is 55 degrees Celsius. That is going to be for benzene. But look at for phenol, you just need to have room temperature. So this is going to strengthen, okay, the part where I say that phenol is more reactive. Yeah, so they are going to actually use room temperature only. Yeah, but if you continue to use concentrated nitric acid, then you go directly to the jackpot. Yeah, 2, 4, 6 directly you will get. Yeah, so that is going to be if you use concentrated nitric acid. Dilute, you still get mixture. Okay, so that is going to be the part for electrophilic substitution. So do remember, Okay, whatever that we have learned, yeah, you refer to phenol. Phenol is more reactive. Yeah. Now, in your syllabus also, yeah, they want you to apply the knowledge of reactions of phenol, okay, to other phenolic compounds like naphthol. Yeah, this is something new, not found in your textbook also. Yeah. So this one, naphthol. Okay, naphthol. There are two types of naphthol. Yeah. Phenol, we know like phenol, they have the one OH. Naphthol is going to be, you are going to have another benzene molecule attached to it. Yeah. So if let's say the OH is at this position, we call it one naphthol. Okay, one naphthol. And if let's say if you have like this and the OH comes over here, this is going to be position 1, this is going to be position number 2, so we call it as 2 naphthol. So we have two types of naphthol. Yeah, so similar to phenol, yeah, similar to phenol, but there is going to be a benzene ring, yeah, another benzene ring over there. Yeah, so this you need to know about, okay, how they will react with, okay, NaOH, how they react with Na, how do they react with Br2, and how do they react with HNO3. Similar like phenol, because just now we learned about phenol, right? So all the reaction with phenol. Okay, so you are going to actually use the same thing. So let's look at naphthol with NaOH. Okay, so naphthol with NaOH. Do remember you have two types of naphthol. So I'll actually draw, okay, this one, okay, and this one. Okay, so I'll copy this, okay, copy, and then I paste it over here. Okay, why I did the like that? Because the OH can come over here. This is going to be one naphthol. This is OH over here. This is going to be 2 naphthol. So now, if I react with NaOH, what will happen? Same thing like what we have done previously. Yeah. So I'll just paste again. Okay. You see here what will happen. You are going to get the O minus and Na plus with water, some sort of phenoxide ion. Yeah, with water. Okay, salt and water will be formed. The same thing over here, you copy and paste. Okay, you are going to get O minus and Na plus with water. Okay, this one is very important. Okay, similar, yeah, similar reaction. Yeah, similar reaction. So that is going to happen when you react with NaOH. Now, let's actually look at Na. Okay, similar also. Yeah, so if you have this molecule of naphtha, okay, let's say OH over here, this one OH over here. So if I react with Na, what will I get? Okay, so the same thing. If you react with Na, you are going to get the some sort of phenoxide ion, yeah, and then you are going to get half H2, okay, hydrogen gas. Okay, reaction will be vigorous. The same thing, okay, you can actually get, you will get the same thing. This one, no need. Hold on. This one, okay, I'll put the O minus and A plus, and then half H2. The same thing that we have learned. Okay, the same thing that we have learned. Just the positions are different, yeah, and the way we draw. Okay, now the reaction with naphthol with Br2. This one, okay, you see naphthol and Br2. This is position number 1, yeah. So you see, yeah, this is one naphthol. Now, one naphthol, do remember OH is going to be 2,4,6 directing. Okay, 2,4,6 directing. So this is position number 1. So they will direct Br to the position number 2. Yeah. And they will direct, okay, the Br to position number 4. Okay. There is no position number 6, so you no need to draw. Yeah. There is no need to draw for position number 6. Okay, so this is all taken from here. Okay, so this one is not found in your textbook, so I take it from Chem Guide. Yeah, so anyway, okay, you are going to get this. Okay, but let's actually have a look. Okay, but do remember, okay, you do not phenol. Yeah, you do not need to have any AlBr3. They are not required because they are more reactive. Yeah, no need halogen carrier. Yeah, and if you look at 2 naphthol with Br2. Yeah. Now, this is position number 2. Yeah, remember, this is going to activate position 2, 4, 6. 2 is already taken by the OH. Okay, 2 is already taken by OH. So the next position is going to be 4, 6. Okay, 4, 6. So you see here 2, 3, 4, 5. Okay, sorry. Hold on. Okay, for this one, okay, for 2 naphthol, the preferred place for the bromine to go is going to be the OH group and the other ring. Yeah, this one is going to be slightly different. Yeah, they say that, okay, you cannot have, okay, position number 4. Okay, they because it's cluttered up with another ring. They say this one you cannot add the Br over here. It's cluttered. Okay, so what they say is, rather than putting it there, okay, they prefer to come between the OH. It means somewhere here. Okay, so this one I think we just follow the one mentioned by the chem guide. Yeah, so they say that the bromine, they will go between the OH group and the other ring. Yeah, so this is the other ring, and then OH, they tend to go here. Yeah, because of something they call it as cluttering. Yeah. So this one, you can see this one is mentioned by the author of the chem guide. Yeah, so this is still new, so I'll just put it over here. Yeah, and naphthol with HNO3, I think when it comes to 1, yeah, so 1 is easier because it's 2, 4, 6. So you can see, okay, at position number 1, position 2, okay, easier. Okay, and then position number 4, easier. Yeah, you can actually predict easily. Okay, but when it comes to 2 naphthol, yeah, with HNO3, so they are going to follow similar to this. Okay, so if I erase this one, okay, and I copy, okay, it's already 10:30. Hold on, I copy and I put it here. Okay, what we are going to expect is you can replace this Br and you change it into NO2. They tend to come in between of OH and the other benzene ring. Yeah, that is going to be additional. This one, you cannot find it in the textbook. Okay, so I included over here. So you just need to learn more on this part. Yeah. So I saw there is one question over here. Hold on, let me answer that. Can Br be at both positions at 1 naphthol? Okay. For 1 naphthol, Br can be both position. Okay, can it be both position? That is going to be maybe if it is going to be in excess. Yeah, Frederick, maybe can. Okay, but do remember in your syllabus, they didn't specify. But let's say they say excess, yes, they can actually be at both position. It means the Br can be also here, yeah, together. Okay, but in this case, I think they follow the normal situation. Yeah, if it is in excess, yes. Okay, so do remember, and that will actually give you more question if it is going to be for nitric acid. If it is in excess, how? Yeah, in excess also, then similar, the NO2 can come over here also. Yeah, but position 2, 4, 6, okay, definitely 6 is not able to be done because I think because of the ring. Yeah, so you don't add anything to the other ring. Yeah, so that is not required by your syllabus. Yeah, so that is going to be the summary of our lesson today. Okay, it's already more than 10:30. You can just go through this. I have covered everything with you. Okay, that's all from me. Yeah, I will stop recording. So